And let's calculate something else, that is the force between two dipoles. As you can see at your screen, we have 2 point dipoles with dipole moments P1 and P2, and they are located at a distance d from each other, and their dipoles moment are directed along the straight line connecting them in opposite directions. And we need to determine the force acting on each of the dipoles. And how can we find this? So let us direct the x-axis like this, along the line of connection of dipoles. Yeah, from dipole P1 to P2, and its origin. I would like to place the origin of x-axis. Origin of x-axis on the location of dipole 1, first dipole, got dipole moment P1, and now the force acting on the dipole moment P2, we need to find it, but we have a general formula that the force acting on the dipole moment P in an external electric field E is given by the formula F equals P dot grad. It is going to be difficult for many. P dot gradient vector multiplied by E vector, and the result is simply Px del E by del x plus Py del E by del y plus Pz del E in vector by del z, and this is the force in vector form, and that is what this statement says. And if you like to watch this problem getting solved, and if you can bear it, let's move ahead. So let's determine the force acting on dipole P2 from the dipole P1. So the electric field at a distance r from the dipole moment P1 is let's say E1. So E1 can be written as simply 1 upon 4 pi epsilon naught 3 P1 dot r vector divided by r5 minus P1 divided by r cube, and this P1 and r, the angle between them is 180 degree. You can see P1 r can be from P1 to P2, this at this location, and the direction of P1 and P2 is they are opposite to each other, so cos 180 degree is going to be minus 1, and we got it is simply as minus 1 by 4. This statement is 2P1 divided by r cube is the result. And now since the dipole moment P2 has only Px component, Py and Pz are missing, you can see in the picture, and r is equal to d, we can use only this thing, this part of expression of the force, and we calculate the force acting on P2 as P2 del E1 upon del x, and this is basically the force acting on dipole moment 2 P2 by P1, and you will get the result simply as 1 upon 4 pi epsilon naught 6 p1 p2 divided by d raised to 4, and this is the result. Del E by del x is quite easy to calculate, and I would like to say that for the dipole orientation specified in the problem, the force acting on dipole P2 will be directed from dipole P1. So the force acting on dipole P1 in the field of P2 will be same in magnitude and directed from dipole P2. Dipoles are going to repel each other, and this is the problem. Thank you very much for watching.